Hi everyone, Assalamualaikum. In this video, we are going to discuss total differentials. We can use total differentials to find the approximate value, right? First, we look at the total differential for function of two variables x and y. Okay, total differential for function of two variables df equals to fx dx plus fy dy. And linear approximation, fxy equals to fx naught y naught plus df. Okay. And the total differential for the function of three variables x, y, and z, total differential df equals to fx dx plus fy dy plus fz dz. And linear approximation for the function of three variables fxyz equals to fx naught y naught z naught plus df. Alright, x here means the given decimal numbers for x. X naught means the nearest whole numbers for x. And dx means small change in x. And then y means the given decimal numbers for y. Y naught means the nearest whole numbers for y. And dy means the small change in y. Okay. Z means the given decimal numbers for z. Z naught means the nearest whole numbers for z, and dz means small change in z. Okay, and from here dz equals to x minus x naught, dx equals to x minus x naught. Okay, dy equals to y minus y naught. And dz equals to z minus z naught. Alright. Now we look at example 1 from the previous semester papers. Use total differentials to approximate the value of square root of 15.98 over 3.04 to the power of 4. Step 1. We need to identify x, x naught dx, and y, y naught dy. Okay. Alright, x equals to the given decimal numbers for x. Okay. X naught equals to the nearest whole numbers for x. So from here, our x equals to 15.98, the given decimal numbers. Okay. And x naught equals to 16, the nearest whole numbers. Okay, so the nearest whole number for 15.98 equals to 16. And after that, we need to find dx. Dx equals to x minus x naught. Okay, so it is equals to 15.98 minus 16. So equals to negative 0.04. Okay. After that, we need to find y, y naught, and dy. Okay, y means the given decimal numbers for y. Okay, so from here, we have the given decimal numbers equals to 3.04. Y naught equals to the nearest whole numbers. So the nearest whole numbers for 3.04 equals to 3. Means 3 is the value for y naught. After that, we need to find dy. Dy equals to y minus y naught, means 3.04 minus 3. So dy equals to 0.04. Okay, positive value. Okay, and then we continue with step 2. Find the function of fxy and the value of fx naught, y naught. From the given question, okay, we can find fxy. Okay, alright. From here, we have x equals to 15.98 and y equals to 3.04. So we replace 15.98 by x and we replace 3.04 by y. So this is our fxy. Okay, so now we done find fxy. Then we can find the value of fx naught, y naught. Okay, so to find fx naught, y naught, okay, we get from fxy equals to third x over y to the power of 4. Then we can find fx naught, y naught. Before that, x naught equals to 16 from step 1 and y naught equals to 3. Okay, so we just replace 16 into variable x here and we replace 3 into variable y here. So we get this. After that, we simplify, so we get 4 over 81. Okay, we leave fx naught, y naught in fraction. Do not leave it in decimal for more precise approximation. Okay. Alright, then we continue with step 3. Find fx and fy and its value at x naught, y naught. Right, so we can find fx from f. Okay, fx means partial derivative f with respect to x. Means that we treat x as a variable and at the same time we treat y as a constant. Right? So from here, we can separate variable y and variable x. So we can write 1 over y to the power of 4 times x to the power of half. Okay. We need to change or we need to rewrite set x in terms of x to the power of half using the properties of set. Okay. Because x we treat as a variable, so we need to differentiate. Okay. Then we can find fx means partial derivative of f with respect to x. Okay. From here, y we treat as a constant means 1 over constant to the power of 4 equals to constant. And x we treat as a variable means x to the power of half here containing x is a variable. Okay. So from here, we have multiplication between constant and variable. Okay. So when we differentiate, we just keep the constant in front and we differentiate the variable. Okay. Using an appropriate technique. In this case, we can differentiate using power rule. Okay. So when we use power rule, we just move the power to the front and then x. And then half minus 1 equals to negative half. Okay, that's why we get this. After that, we can simplify. So we get 1 over 2. Then we move down x to the power of negative half. So we get x to the power of positive half, which is equals to third x. And then times x to the power of 4. So this is our fx. Okay. Alright, after we find fx, we can find its value at x naught, y naught. So at x naught, y naught means at x naught equals to 16 and y naught equals to 3. Okay, so at 16, 3. Our fx equals to 1 over 2. We replace x by 16 and we replace y by 3. After that, we can simplify. So we get 1 over 6, 4, 8. Okay. We leave fx in fraction. Do not leave it in decimal for more precise approximation. Alright. Alright. From the previous slide, we get fx equals to 1 over 6, 4, 8. Okay. Then we can continue with fy. Okay. Fy means partial derivative of f with respect to y. We treat y as a variable and at the same time we treat x as a constant. Okay, we can find Fy from F. Okay, in the previous slide, F equals to Zx over y to the power of 4. Okay, we can write F equals to Zx times y to the power of negative 4. Okay, from here, we want to find Fy. So, we have division function here, but we only have variable y in denominator. So, no need to use quotient rule. We can move up variable y here. Then we get multiply by y to the power of negative 4. For set x here, we no need to change into the form of x to the power of half because we treat x as a constant. So, no point if we change into the form of x to the power of half, okay? Because it's still constant, okay? Alright, so from here, we can differentiate with respect to y, okay? Using partial derivative, okay? Then we get this, okay? Alright, from here, we have set x equals to constant because we treat x as a constant, means set x also constant, okay? And we have y here, okay? We treat y as a variable, okay? And then when we move up, we get y to the power of negative 4, okay? From here, we have multiplication between constant and variable. Okay, so when we have multiplication between constant and variable, when we differentiate, we just keep the constant in front and then we differentiate the variable using an appropriate technique. In this case, we differentiate using power rule. So we move power to the front, so we get negative 4 in front here, and then negative 4 minus 1, so we get y to the power of negative 5, right? And after that, we simplify, so we get negative 4, third x, and then we can move down y here, so we get y to the power of positive 5, okay? So now we done find Fy. Then we can find its value at x naught, y naught. Okay. So at x naught, y naught means 16 from the previous slide. And y naught equals to 3. Okay. From the previous slide in step 1. Okay. Then we can find Fy at x naught, y naught. Okay. From here, Fy equals to negative 4 third x over y to the power of 5. We replace x by 16 here. And we replace y by 3 here. Then we simplify, so we get negative 16 over 243. Okay, we leave Fy in fraction. Do not leave it in decimal for more precise approximation. Right? And then we can continue with step 4 after we done find fx and fy and its value at x naught, y naught. So we can continue with step 4. Use df equals to fx dx plus fy dy. df means total differential. Okay. So from df equals to fx dx plus fy dy, so our fx equals to 1 over 6 for 8. dx equals to negative 0.02 from step 1 in the previous slide. And then plus fy. fy equals to negative 16 over 243 times dy. dy we get from the first step in the previous slide, which is 0.04. Then we solve, so we get df or total differential equals to negative 0.0026646. Okay. And then we continue with step 5. This is the final step. Okay. Approximate the given value, means this value. Okay. Right, so we have square root of 15.98 over 3.04 to the power of 4. Approximate to, Alright, the formula is f x naught y naught plus df. Okay, f x naught y naught we get from step 2. Okay, so we have from step 2 we get 4x naught f x naught y naught equals to 4 over 81, and then plus df from step 4 we get negative 0.0026646. Then we simplify, so we get 0.0467 up to 4 decimal places. Okay, so this is the answer when we approximate square root of 15.98 over 3.04 to the power of 4 using total differential. Okay, we can check the answer. Okay, we can use calculator, straightforward from calculator. So we get 0, after we use calculator, we get 0.0468 up to 4 decimal places. Okay, so means that the answer almost accurate. Okay. Coming up next, more examples for total differentials. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.